Hi, so we're going to work through a couple of examples of correlation and regression problems. And I first wanted to go through a problem that's in mystatlab, and then we'll do one that'll be like the graded problems. So in this problem, we're using people's diastolic blood pressure to predict their diastolic. So the first thing we want to do is they ask, is there sufficient evidence to conclude that there is a linear correlation between these two? So the null and alternative hypotheses would be, the null hypothesis is always rho equals 0, and then the alternative is rho not equal 0. So we got that one right. So now we need to do a scatter plot. To do that, I wanted to show you, you don't have to type these values into StatCrunch yourself. If you see this little button right here, you can just click that and go to Open in StatCrunch, and it'll automatically type that data in for you. So we want the scatter plot. Now everything we're going to do is going to be all in one place, so you don't have to go to different places to get these different things. So for all of these problems, if you just go to Stat, Regression, Simple Linear, our X variable is systolic, the Y variable is diastolic, and if you remember from the PowerPoint, we said that testing the slope on the regression equation is the same as testing whether the correlation equals 0 or not equals 0. So we'll leave that as not equal 0, and we don't want to do this. We don't want to do any prediction of y. We might later, but we want the fitted line plot, and then that's all we need. So we'll just do compute. And if you see here, this says this is page 1 of 2. On page 2 is the scatter plot. So we can look and compare the scatter plot to what we have over here. And it's definitely increasing. And the lowest one is 120 and 80 something, and then there's sort of an extreme observation up here. So we'll look for those features on here. Okay, so it's definitely increasing. The lowest one we said was, what did we say the lowest one was again? 120 to 80, and we have an extreme observation up top. Well, this one looks on the surface like the most like it, but if you see the value down here is centered at 0, so we don't want to do that one. This is the one it needs to be, because 120 and 80. So we'll click on that one. So it's not necessarily to the same scale. Okay, so we got that one right. We need the linear correlation coefficient. So if we go back to our output, the linear correlation coefficient is listed right here up top. It's 0.6858, so we'll round that to 0.686. So 0.686, and we got that right. The test statistic. Now on this output, the test statistic and p-value are listed there for you under this parameter estimates. You don't need anything from the analysis of variance table. Parameter estimates, but make sure you're looking at the slope row, not the intercept. We don't do anything with the intercept. So this value right here is our test statistic, so 2.980. So 2.980, we got that right. And the p-value is on that same row, the slope row, down to p-value 0.014. So 0.014, we'll check our answer, we got that right. Okay, so now the conclusion. Is our p-value less than alpha, which is 0.05? This is less than alpha, so less than. If the p-value is less than 0.05, that means there is sufficient evidence to support the claim that there is a linear correlation. Alright, and that's it for that problem. So one of the main things I wanted to show you there was this thing right here, so you don't have to type in the values. Alright, so we'll call it good for that example, and I'll do a separate example for the other one. Alright.